what I'm here with now is the next topic from organic chemistry. Actually, I started a day before, but I couldn't, make it, yesterday with the next topic. So what next topic I'm, talking right now is the nomenclature of, haloalkanes and haloarenes. Earlier, I, told you what haloalkanes and haloarenes are and how they are classified. Now it's time to talk about their, IUPAC nomenclature, right? So let's see whatever is possible there. Let me try to do that and talk about the IUPAC name. Before I even start you with IUPAC name, I'll tell you some basics thing. And these basic things, even the students in their 10th standard can, understand. Even their 9th standard, 11th, or whatever standard they are having problem with the naming, they can go through that. So the first thing is that, in organic chemistry, one of the carbon, if there is one carbon, it's called meth. If there is one carbon, it's called meth. If there are two carbon, it's called eth. It's called eth. Then there are three carbon, it's called prop. If there are four carbon is called but. If there are five carbon, they call it pent. Even you call it pent. If they have six carbon, they call it hex. If there are seven carbon, they call it sept or hept. They call it sept or hept. Okay, if there are eight carbon, the eight carbon compounds are called oct. Similarly, the 9 one is called non. The 10 one is called dec. 10 one is called dec. Right? Similarly, there are some 11, 12 and all. We will learn that, but we'll be using most of the time these. So let's talk about another thing before we even start with the nomenclature. What next is, based on the number of groups in a compound, in an organic compound, right? So what you can do is like, if there is one functional group, it's called mono. There is mono. Therefore, two, it's di. Therefore, three, it's tri. Right? If there are four, it's a tetra. It's a tetra. If there are five, it's called penta. If there are six, it's called hexa. Seven, it's called septa. Septa, you can also call it hepta. Okay, then there is octa. So I write this 1, 2, 3, 4, 5, 6, 7, 8. Similarly, 9 is going to be nona. Nona is not somebody name here. Nona is the name of, a name for a group that is in 9 in number. And similarly, 10 is going to be for deca, right? So deca. So these are some of the basics you need to understand. The third basic thing I'm taking you is what is an alkyl group. You need to concentrate here. Alkyl group, right? Alkyl group. Okay, so what alkyl group? An alkyl group is made by alkane minus hydrogen atom. You need to understand alkane minus hydrogen atom. For example, if there is methane, this become methyl. This become methyl. I hope you CH4 minus H, this makes you get CH3. So this is called methyl, right? So methane to methyl. Methane to methyl. Similarly, ethane, I'm not writing the formula because I know you understand. So this is going to be ethyl, right? Then propane, this will form propyl. So these are some of the basic things I will be using. So this one is very, very important. It's called functional group. What functional group? A functional group is an atom. A functional group is an atom or group of atoms that decides the properties of organic compound. That decides the properties of organic compound. Right? So, what is a functional group? A functional group is an atom or group of atom, and that decides actually the properties of a compound. What kind of properties? Not only the chemical, but also the physical properties. Chemical and physical properties. Physical properties. So, all the properties of a compound are decided by the functional group. So I'll let you know right now what are the major functional group and what are their importance. So the next thing I'm going to do is priority series of functional group, right? So the next thing is that priority series of functional group. Priorities series of functional group. Functional group. Right? So you do know there are so many functional groups here like carboxylic, amine, ester, alkyl, halogen, and many more. But how they are used and what are their sequence to be followed while naming, that is I'm going to do. But can I get a minute? What are the functional groups that are used in priority series? The first, the most important one is carboxylic group, right? So the carboxylic group is carboxylic group. Carboxylic group formula is COOH, right? And then you have sulfonyl group. Sorry, sulfonyl group. Sulfonyl group. Sulfonic group, that's much better. Sulfonic group. Sulfonic group formula is SO3H, right? And then you have ester. You need to understand that there are something always such as ester, and then there is a acyl group and all. So the next one is ester group. Ester group. What formula for ester group is? ROOR. Right? So this is the ester group. And then there is acyl group. Let me write the name first. It's ACYL, acyl group. So the acyl group formula is RC double bond O. I hope you can see. If not, let me make this bigger. RC double bond O Cl. So okay. So what next time? I'm continuing over there. Okay. So what next is you need to understand that these priority series are really very very important. So what you can do is like what you can do, you must remember then. What next is you have amide here. Amide is like R C double bond O NH2. This is called amide group. Again, I am trying to mess up. So it's called amide group. Amide group. So formula for amide group is R C double bond O NH2, right? Amide group. After amide group you have cyanide group, right? Cyanide, which has a triple bond. What I'm doing, man? Cyanide. I'm writing the name. Cyanide group. So cyanide group has a formula of CN. And then what then you have is like amine group. You have then coming up out to be aldehyde ketone. You need to understand. So the next is aldehyde. Sorry, HYDE, aldehyde group. Aldehyde, the formula is C double bond O and H. So this is the aldehyde group, right? And after aldehyde, you have ketone group. What ketone group is? RC double bond O, and it may be R dash also. So what the hell is going on here? So it's ketone here. The next one is ketone. And what formula for ketone is? R, C, double bond, O, and then there may be another R here, right? Okay, then you have, then you have a hydroxy group, then you have amine group and alkene, right? So let's take another one. Then you have a hydroxy group, OH. It's hydroxy group. What formula for hydroxy is? OH negative, right? And then you have amine group. Amine, A-M-I-N-E. So the formula is NH2. And then you have finally, alkene group, A-L-K-Y, alkyne, that's represent to a triple bond. And finally we have alkene. That is C, no. First we have alkene, and finally we have alkyne. So I took so much of time. Let me explain you what these two are coming out to be. Functional group is an atom or group of atoms that decides the properties of a compound, which is not only the physical but also chemical property. This is really very, very important. Everything has something very unique, and that uniqueness decides what kind of person that is. So that is actually the functional group here. And there are so many functional group here. Maybe some of them are even I'm missing right now. But I have made a series of these functional groups based on their priority series. What is this priority series? This priority series will help you while doing the IUPAC naming, like which one will be considered to be used as a last one, or which one is going to be in the middle one and all. So the priority series simply tell you which is the most important functional group. So first one is carboxylic, COH, then is sulfonic group, SO3H, then there is ester groups, ROOR, you can also have COR. Then there is acyl group RCOCl. You need to understand that RCO single bond Cl, acyl group. And after acyl group, you have amide group is RC double bond O NH2, right? This is amide group. You need to remember all of them. Cyanide, you have idea what cyanide is. Aldehyde, you do know because this is very common for you've been doing for last so many years. And after aldehyde, you have ketone. You also know what ketones are. And then from the ketone, now it's to hydroxy group. From hydroxy, you come to amine, and then alkene, and finally alkyne. So what that means, alkyne group has the least priorities when it comes to use in the nomenclature. So alkyne group has the least importance, while carboxylic group has the most importance. How these are used, I will let you know, but let me continue with some other stuff also. There are two types of group, functional group actually. There are two types of functional group. Functional group, right? There is prefix group. What that means, you can use them as prefix, and then there is a suffix group. Okay, so prefix groups are halogen. All the halogens are prefix group. What that means, chlorine, bromine, and iodine, they will always be used as a prefix. Then there is nitro. Nitro, what the formula is? NO2, right? So this is also that one is the prefixing group. There is another prefixing group, and the third one is alkyl group. I just let you know earlier. So it's alkyl group. So these are the groups which are used always as a prefix, but based on their alphabetical importance. You need to understand that they are used on the basis of alphabetical order. Alphabetical order importance, right? I'll use it and then I will let you know how useful this is. Alphabetical importance, right? But suffix are what? Suffix are actually, either alkanes are suffix, and other functional groups. You need to understand other functional groups are also the suffix. But if there are more functional group in a compound, then I'll let you know once I do that, because this requires practice. So let me help you with that. There are two types of functional group. One is of prefix type, other is of suffix type. These halogen nitroalkyl group, they are always used as a prefix group, and they are used in alphabetical order. Other functional group like those aldehyde, ketone, carboxylic, acyl, amide, whatever, they will be used as a suffix, right?